So, when you're solving a combination circuit, you have to realize the first thing is that it is made up of parallel and series circuits, okay? This is a parallel circuit. This is a parallel circuit. The combination of these two is a series circuit, okay? So this parallel circuit 1 is in series with parallel circuit 2, okay? So the first thing that you have to do is turn it into one simple circuit. You have to turn the two parallel circuits into two resistors into one resistor. So to do that, you have to find the REQ. 1 over REQ, based on the reference tables, is equal to 1 over 100 plus 1 over 250, because that's 1 over resistance 1 plus 1 over resistance 2.
Victor, please report to the main office. Victor, please report to the main office.
You have to find the greatest common multiple and change the denominator to that. So the greatest common multiple for these is 500. So 1 over 100 turns into 5 over 500. 1 over 250 turns into 2 over 500. Add them together, 7 over 500. And that is equal to 1 over REQ. So the last step is always to flip it. So that becomes 500 divided by 7. 500 divided by 7 is 71.4. That's rounded, but that's okay. We're going to round it. Now we do the exact same thing for the second parallel circuit. 1 over REQ is equal to 1 over 350 plus 1 over 200.
Victor, please report to the main office. Victor, please report to the main office.
The least common multiple is 1 over 14, or is 1400. So this turns into 4 over 1400, and this turns into 7 over 1400. Add them together, 11 over 1400. 1 over REQ is 11 over 1400. Flip it and divide. 1400 divided by 11. And then your resistance is 127.3. Okay? So we've turned these two parallel circuits into series circuits. So I'm going to redraw it. I have a 24-volt battery. I have one resistor that is 71.4 ohms. And I have one resistor that is 127.3 ohms. And this is all attached to a 24-volt battery. Now I have a simple series circuit. I can find the total resistance by adding those two together, because now it's a series circuit based on the equations in your reference tables. The total resistance in a series is found by adding all of the resistors together. 71.4 plus 127.3 is 198.7. Okay? To make it easy, I'm going to go ahead and round that to 200. So to make it easy, the total resistance is 200. Now I can use that to find the total current by using Ohm's law, V equals IR. 24 volts is equal to 200 ohms times a current. Divide both sides by 200. And my amps, my current, is 1.2 amps. Now, the current stays the same in a series based on the reference tables. I total is equal to I1 is equal to I2 is equal to I3. So the current going through this resistor is 0.12 amps, and the current going through this resistor is 0.12 amps. In a series, the voltage divides. So the voltage total is equal to the voltage 1 plus the voltage 2. We can find the voltage for these two resistors by multiplying the resistance and the current. So I'm going to do 71.4 times 0.12, and that gives me a voltage of 8.568. 127.3 times 0.12, the voltage is equal to 15.276. Now, in theory, those should add up to 24, but because I rounded the answer, it's not going to be exactly 24. But that's okay. We're just trying to get the concept. Now, we have to split these two resistors back into parallel circuits, okay? So, this total parallel circuit has 71.4 equivalent resistance, has a current of 0.12 amps, and has a total of 8.568 volts. This parallel circuit has a total of 127.3, which is its REQ, equivalent resistance. It has a total current of 1.2 amps, and it has a voltage of 15.276. So now we can find the current and the voltage through each one of the parallel resistors. They already gave us the resistance for each of the four resistors. The equations on the reference tables that refer to parallel circuits say that the voltage stays the same in each of the branches, okay? So the voltage in the first parallel circuit is 8.568, and that's going to be the same for resistor 1 and resistor 2. Okay? So resistor 1, voltage 8.568 volts. 8.568 volts. Resistors 3 and 4 are parallel. Voltage stays the same through the parallel branches. So if the total voltage is 15.276, that means that the voltage in each of the branches is 15.276. And then, whoops, I switched these rows. So, let me rewrite them. So now you can solve for the current by setting each of these columns up to Ohm's law. So all you do is divide the voltage through each resistor by the resistance. So for resistor 1, 8.568 divided by 100, 0.086. Resistor 2, 8.568 divided by 250, 0.034. Resistor 3, 15.276 divided by 350, 0.044. And resistor 4, 15.276 divided by 200, 0.076. And that's how you solve a combo circuit.